Hello. I'm going to use these numbers again. I'm going to be aware of the greater than side of the equation. If we're in imbalance, A will be greater than B, or B will be greater than A. If A is less than B, this will go tip this way. If A is greater than B, things will tip this way. But we're going to be investigating the equilibrium point. We're going to see how close we can get to equilibrium, and we're going to do the math to get it right. We're going to do the numbers to see what's safe. Sometimes it's fun to make things topple over, but sometimes it's more amazing to make them balance. So we're going to be investigating equilibrium or equality or the equal sign. I'm going to be playing around and predicting what numbers go together to create equilibrium or equality using the equal sign. To make sure that things are fair in the test, I'm using this. It's got bubbles in, so I'm going to put this on here like this, and with the bubble completely flat in all directions, I'm confident that I can continue on with the experiment. So I have a worksheet here which I'll be revealing shortly. I'll move this to one side and this to one side and bring in the weights. So the weights, as I described before, 2.5 pounds and a 10 pound weight. And this is a broom handle, mop handle. It's hollow, so it's very, very lightweight. Sturdy, but lightweight. So actually, as far as the weight of the system goes, it's hardly anything. So I can ignore it in most of my calculations. And you'll see how I can use this to my advantage shortly. So first of all, let's have a look at our first question. Our first question is, I'm going to put the 5 pound weight on interval 1. I'm going to put the 2.5 pound weight somewhere. The number is missing. So I have to think 5 times 1 equals 5. So what number do I need to multiply 2.5 by to get 5? You hold that answer in your mind. So right now, this is on this point, and this is on this point. There's an imbalance. This side is greater than that side. So I have to do something. So, I already asked you what I should do. What's the math? How many times do I need to multiply 2.5 times by to obtain 5? 2. Well done. So put this on the 2 point. This should balance nicely in the middle. Next one underneath, I want to move this weight further over. So now I've got an imbalance again. So the question is, what does this amount to? 2 times 5? 10. What's this weight set at? 2 times 2.5, that's 5. So yes, 10 is greater than 5. So I need to move this outwards. So by how much? Let's try the experiment. 1, 2, 3. we go, very close to equilibrium. 1, 2, 3, 4. So that's what reality is telling us. Now let's look at the work. 2.5 times 4. 4 times 2 is 8. 0.5 times 4 is 2. 8 plus 2 is 10. We have a balance. Now we're going to go start playing around with heavier weights. From an earlier video I showed that this is a 10-pound weight and it's the equivalent to a 10-pound bag of potato, 10-pound bag of sugar, 10-pound bag of anything. It's quite heavy, so my small pole here, my mop pole, might not be able to withstand the weights that I put upon it, so I'm going to switch over to a metal pole.